Okay, so guys, today we're going to talk about symmetry. How many of you have heard of the word symmetry before? Oh, thank goodness. I'm so glad some of you are raising your hands. Okay, put your hands down, please. All right. How many of you could pretty much explain to me what symmetry is and show me what it is really easily? Okay, put your hands down. Thank you. How many of you could probably do some problems if I gave you problems on symmetry to do? Okay. How many of you would really be happy if I tell you more about symmetry right now? Okay, great. All right, so I'm going to do that. So we're going to talk about symmetry. Symmetry is basically when you can fold something in half exactly, it has a line of symmetry in it. Okay, so if I draw a picture, I want you to tell me if you think this has a line, how many lines of symmetry this has. Okay, this is supposed to be a square. I want you to show me with your fingers how many lines of symmetry you think that square has. Okay, how many lines of symmetry? How many ways can I fold this square so that it's going to be exactly in half? Okay, I'll show you how many ways. A square actually has 4 lines of symmetry. Okay, we should have one this way, because look, oops, except it should be straight, not wiggled. All right, if I do this, I could fold it exactly in half and it would match, wouldn't it? Like a piece of origami paper, for those of you who like origami. And how about this way? I could fold it in half this way, couldn't I? From top to bottom, and it would match. Look right up here so you can see the lesson, please. Okay, it would match, wouldn't it? All right, and then if I divide it diagonally, okay, how many of your moms or dads or whoever makes you sandwiches, look right up here so you can see where it's happening. If they make you sandwiches, we'll cut your sandwiches in a diagonal. Okay, so that's a line of symmetry that they're cutting your sandwich in. All right, I mean, not exactly, because your bread's probably not exactly square, but if it were, that would be the idea. And here is the 4th line of symmetry, is the other diagonal. Okay, so we can kind of look for lines of symmetry in different shapes. Okay, we've talked about different shapes. That one's a square. How about a rectangle? Show me with your fingers how many lines of symmetry you think a rectangle has. Okay, you should be able to show me on one hand. Okay, a rectangle will have 2 lines of symmetry. Okay, we'll have 2 lines of symmetry. One right down the middle, here, because, look, I can fold that rectangle right in half, all right? And we can even try this with some paper. Right now I'm just kind of demonstrating to you some examples. And I could also fold it in half from top to bottom. But if I try to fold a rectangle corner to corner, it's not going to match. Okay, it's going to be all cockeyed, all right, and all over the place. It's not going to match at all, all right? And these are things that we really kind of have to play with paper a little bit, and so you can make your own shapes and see. How about an equilateral triangle? How many lines of symmetry is this going to have? So let's say all these sides are equal. How many lines of symmetry is it going to have, do you think? Show me with your fingers. Oh, okay, interesting. I bet you guys, you're telling me 1, so this had 2. You're telling me 1, I bet you're seeing this one, aren't you? Are you seeing this one? Give me a yes or a no. Okay, watch. Because it's an equilateral triangle, this triangle is going to look the same if I roll it over onto its side. It's still going to look just like this, right? It's still going to look just like this. And if I rolled it onto its side like that, look where that line of symmetry just ended up. You see that? See what happened with that? Do you see another line of symmetry that just appeared now? Raise your hand if you see another line of symmetry that just appeared. This one? Is this the one that you see? Okay, now watch. I can roll it one more time. Okay, and look, since it's equilateral, since all the sides are the same, it looks the same when I roll it again. So I rolled it, and this time I rolled it, so that first line of symmetry went to there, and now it's over at this corner. And then this line of symmetry rolled to here. Okay, and now I bet you guys see this one straight down the middle again, don't you? Okay, so equilateral triangles are really cool because they actually have 3 lines of symmetry. That's only an equilateral triangle, though. That's only equilateral triangles. What if we look at lateral? What if we look at an isosceles triangle? Okay, what if we look at an isosceles triangle? where two sides are the same and one side is different. How many lines of symmetry do you see there? Okay, you should see one. All right, if I roll this onto its side, just like I did that, look what's going to happen to it. This is going to come up here, so it's going to look like this. Okay, it's not going to be as easy to roll around as that guy. All right, so an isosceles triangle is just going to have one, because if I try to do that, it's not going to be equal. All right, that's isosceles. Isosceles. How about a scalene triangle, where none of the sides are equal length? How about a scalene triangle? What do you think? How many lines of symmetry do you see there? I drew it kind of tiny, but that's the idea. Show me with your fingers. I want to see everyone show me how many lines of symmetry you see. Look right up here so that you can show me how many lines of symmetry you see. Very good. You should see 0. Okay? There are 0 lines of symmetry in a scalene triangle. Okay? And that's because there's no way that you can split that evenly, straight in half with a straight line. Okay, lines of symmetry, we can't have like zigzag and curved lines. All right? Not with what we're talking about. We're talking about just straight lines here. All right? So different shapes have different lines of symmetry. Any questions about that?